Hello there, everybody. This is lesson 2.3.3. It's called the Pythagorean theorem. Last few days you've learned how to determine what kinds of values the sides in a triangle can have. You've also learned how to find the length of the longest side in a right triangle. And that process was a little long and kind of involved a lot of stuff, and it'd be nice if we had an easier way to do that, an easier way of finding the missing side in a right triangle. For example, if you knew what these two sides were, it'd be nice if we had an easier way to find the length of this third side. And that's what we're going to do today, is figure out that easier way. Here you see I've got 4 triangles here. I'm going to arrange them hopefully in a familiar, or in a pattern that's familiar to you from a lesson a couple days ago. There we go. So we've got our four triangles in there, and we've got a square on the inside, and the length of this side here is C. That says right there, and the length of this side is also C. So that means the area of this square is C times C. And C times C is C squared. Now I'm going to make a little note of that here. That's the area of this blank square in here. Now I'm going to rearrange the triangles a little bit. They're still all going to be inside, but they're just going to be arranged again a little differently. There we go. Now the blank part is 2 squares. This square over here is b times b, which is b squared. This bigger square over here is a times a, which is a squared. And the total area of those two is, so that's a squared plus b squared. Just add the two areas together. Now, by rearranging these triangles, do I change the area? I mean, do I change the amount of the area in the squares, in the square? No, you don't. So c squared, what we got before for the blank, for the blank area, the area of the blank part, has to be the same as what we got here, because rearranging these triangles doesn't change that blank area, that area where it's just the white there. It's not the triangles. So those have to be the same. And this equation this formula is called the Pythagorean theorem. And this is going to give us an easier way to find a missing side in a right triangle. So again, here's our right triangle. We just showed that c squared equals a squared plus b squared. There's a couple of things that you need to know. This side that's c right here is called the hypotenuse. It's the side that's opposite the right angle. And whatever number, we're going to do a couple of examples here, and whatever number you put in here for c has to be the side that's opposite the 90-degree angle. Okay, that's called the hypotenuse. That value always has to go here. The other two are called legs, and those are a and b. These two sides, they're interchangeable. They can go in either position here. But the important part is that the hypotenuse, the longest side, goes right here. So let's see a couple of examples here. How are we going to use this? So let's say we've got a right triangle. Here's our right angle. Let's say this side is 6, this side is 8, and that side is x. And we want to find that missing side. Now we had a long process for doing it in a couple lessons ago. But this time we're going to use the Pythagorean theorem, and it's a lot easier. Okay, so let's write the formula down here. Now the longest side, it's also called the hypotenuse, is the one that goes here. And that number is x. So we'll put x in for c. The other two sides are a and b, 6 and 8. They're interchangeable. I could put 6 squared plus 8 squared, or I could put 8 squared plus 6 squared. Either way, you're going to get the same answer. The important part is that you put the hypotenuse, the side that's opposite the 90-degree angle, in here for C. If you do that, you're going to be okay. So let's solve this equation. 6 squared is 36. 8 squared is 64. If you add those together, you get 100. Now, x squared is 100. In order to undo squared, you have to square root it. So x is actually the square root of 100, which is 10. So the length of that missing side is 10 units. That's a lot easier than that process that we used a few lessons ago. Let's try one more. Here is another right triangle. Let's say this side is 2. Let's say this side is 9, and we're looking for this side here, y. That's our Pythagorean theorem. C squared equals a squared plus b squared. Now, which side do we put in here for C? Again, it's the hypotenuse. It's the side that's opposite the 90-degree angle. In this case, that's the 9. So the 9 goes in here for C. A and B are the other two sides, y and 2. They're interchangeable. We could put y squared plus 2 squared, or we can put 2 squared plus y squared. Either way you do, it's fine. As long as you've got the longest side right there, you're okay. Now let's solve. 9 squared is 81. 2 squared is 4. And we want to get rid of that 4, so we're going to have to subtract 4 from both sides this time. And that gives you 77 equals y squared. And to undo the squared, you square root both sides. That gives us y equals the square root of 77, which I'm going to have to use my calculator to figure out. Square root of 77 is, rounded to the nearest tenth, about 8.7. And that is our lesson on Pythagorean theorem. Hope this made sense. We'll see you in class tomorrow.